Now let's try to understand the difference between force, traction and stress. Okay. So force acts at a point, we know this, and it is a vector. So let's take no, a body in xyz coordinate. So let's take a simple body. Okay, it's not infinitesimal cube or volume. It's we have just given a nice shape to a body, and this is force. So force is a vector, and we can describe force as a define force as in a vector form like this: F1, F2, F3. So the force is very clear. Then traction. So like force, traction also acts at a point, but with respect to reference surface normal. Okay, and it is actually a force intensity of the force which acts at a point with respect to surface normal. Uh, so at macroscopic level, it is a point. In at microscopic level, it acts at a infinitesimal area. Okay, delta A, which tends to 0, becomes point. Okay, so let's take this same cube structure. Okay, let's take this is the cut section. So this is a cut section. Okay, and this is a traction. This surface or cut section is defined by its normal n, and traction can be in any direction t. But this traction will have three components in xyz direction. Okay, so it can be resolved into three components: t1, t2, t3. Okay. Now comes stress. Unlike like traction, stress also acts at a point. Okay, with respect to infinitesimal cube. Okay, infinitesimal cube or volume. So the traction, we say like it is a intensity of force. Okay, let's write down here: intensity of force acting on infinitesimal cube infinitesimal area. Okay, which is described by its normal n. Okay, normal n. And stress is also acts at a point with respect to infinitesimal volume. So we can say this also represents intensity of force. Okay, acting at a point inside material. Okay, so this is inside material. This is the difference. Both are intensity of forces. Okay, both have same units, Newton per mm square, but stress is defined with respect to infinitesimal volume. So if you see like force we are defining at a point. For traction we are digging one level inside. Okay, we are defining a cut plane. Okay, and defining the intensity of force. Then when it comes to stress we are further going into one advanced no one level advance, like from a plane we are going to cube or volume. Okay. So if I just represent that similar cube, okay, cube structure. So this is x, y, z. Okay. This is a structure, cube structure, which is subjected to external force. Okay. So internal the intensity of force. Okay. Uh, inside material. Okay. Intensity of internal force inside material, and obviously inside material means the point. Okay, the point is surrounded by volume. Okay, so this is defined by a stress. So if at macroscopic level it is point as we discussed, but for microscopic level, okay, this becomes the infinitesimal cube element. Okay, so we say delta p. So now the difference should be clear. Okay, the force acts at a point, traction acts at a point with respect to infinitesimal area. Okay, and it is intensity of force. Stress is also intensity of force. Okay, and it also acts at a point, but with respect to infinitesimal volume instead of area. Okay, so in traction the point is surrounded by or defined by area. Here the point is defined by volume at a microscopic level. So hope this is clear, and in next section we'll see how we are going to derive the stress. Okay, we have seen how we derive the traction from the force. Now we'll see how we derive the stress from the traction.